Okay, kids, let us go for the next topic that it's about like angles, the arcs and the central angles. So an arc, a central angle, is the angle made with two radii, no? O sea, we're gonna say that a central angle is an angle that goes from the center to 2 points of the circumference. It goes from the center. Eh, Maybe, o sea, then we're gonna be talking about like inscribed angles that go from the circumference. I am not talking about inscribed angles. I am not starting the angle from anywhere. I am talking about angles that start from the center. Okay, so this is a central angle, an angle that starts from the center. And now sometimes instead of writing the central angle in here, I'm gonna write it as like a piece of the circumference. So I'm gonna say that this piece of the circumference measures 50. Like look at this problem. So I'm gonna say that this piece of circumference measures 85. And what does that mean? That this angle measures 85. O sea, and this is an important gigantic highlight that I put in here. The measurement of the arc is the same of the measurement as a central angle, no? O sea, like an arc is made out of like 2 points, and those 2 points have a couple of radii, and that angle is the length of the arc. Okay. Whenever I have an arc, I have two arcs, no? O sea, like I have the minor arc, the smaller one, and then I have the major arc, no? The big one. Whenever I refer to the major arc, I will talk about it because I'm a freak. I will use 3 points. O sea, instead of saying like arc AB to refer to this thingy, I'm gonna say arc ACB, no? Because there is an intermediate point in here, no? So to name the major arc, I will use 3 letters. And whenever I'm using only 2 letters, I'm gonna be talking about the small arc. Okay, and so today, or well, in this video, I'm gonna do some exercises concerning with these two facts. The fact that if I have congruent chords, o sea, like if this chord and this chord measure the same, then this angle and this angle measure the same. Congruent chords subtend congruent arcs and vice versa. O sea, like if I have this arc to be the same as this arc, then these two chords measure the same. Okay, that is one fact, and the other one is that if I have like a diameter perpendicular to a chord, I am splitting it in half. O sea, that is the meaning of bisects, no? Bisects is that I am splitting it in half, cutting it into two congruent parts. What I want you to get from this is that if I am cutting in 90 degrees, I am cutting in half. If I am cutting a chord in 90 degrees, I am cutting it in half. So, the two facts. Are you ready? Let's set go. Here, let's see. So here I have a diameter that is perpendicular. That means that this diameter, because it is cutting perpendicularly, it is cutting in half. So that means that this measures 5. So this measures 5. Okay, now look. This chord measures 10. And this chord measures 10. So what can you tell me about these two angles? Well, these two angles have to be the same, no? And now, if I am just grabbing half of that angle, that means that y is 43. Okay. Let us see this one. Look, I am cutting perpendicularly. This line is cutting in a 90 angle degree. What does that mean? That means that I am cutting in half. So this thingy measures 3. Okay, so if this thingy measures 3, then the whole thingy measures then the whole thingy measures 6. If the whole thingy measures 6, that means that this angle and this angle measure the same. So if those two angles measure the same and those two chords measure the same, then these two distances, this one, and this one also measure the same. So if this is 4, then this one is 4. Hope that you agree. Okay, now it is the same but a little bit more complicated. So because I have because I have this same two chords being congruent, that means that these two lines are congruent to each other, no? O sea, this line is congruent to this line. In this case, I need to write an equation. My equation is 4x plus 3, this part, equals 7x minus 6. Okay, I subtract the 4x, pardon, 3x minus 6. I add the 6, that is 9, equals to 3x. I divide by 3, and that means that x equals 3. Super cool. Find the measurement of the arc. So I need to find the measurement of arc RS. O sea, I need to find the measurement of this piece. How do I find the measurement of that piece? Well, I know that that piece corresponds to the same as this angle, no? This and this are the same. These two things are the same because that is how we define arcs, no? By central angles. Okay, and what happens with this angle and this angle? They are the same because they are vertically opposite. And so that means that this angle is also the same to this one. By transitivity, a fancy word that we learn while doing proofs, I have that this red part is the same as, o sea, this red part is the same as this purple part. O sea, I can write the equation 8x plus 1 equals 7x plus 9. I subtract 1 on both sides, so 8x equals 7x plus 8. I subtract 7x, so x equals to 8. Okay, but I haven't finished because I want to find arc RS, so I need to plug in x in here. So that is 8 times 8 plus 1, that is 64 plus 1. My arc measures 65 degrees. Good. I am not going to do this problem, but I'm going to walk you through how to do it. So this is very interesting because if this angle measures 120, then this angle measures 120. So x plus 48 and x plus 86 equals 120. From there, you write an equation, solve for x, and because they are asking you for GEH, you plug the value of x in here. Híjoles. Kids, whenever you are in a geometry class and the problem has no drawings, you can tell that this is a tough cookie. Okay, whew. Take a deep breath. So, let's draw a circle. I'm going to draw a circle with fancy technology. Cool. Okay. It says that I have a chord that it is a distance 5 from the center. So I have a chord. Let me draw a chord. I have a chord, and this chord is a distance 5 from the center. Okay. And the circle has a radius of 8. O sea, that means that a radius measures 8. And they are asking me to find the length of this chord. Okay, so what do you feel like doing? I feel like instead of drawing my radius in here, o sea, I'm not going to draw it in there. Whoopsie. I'm going to draw it in there because I cannot erase it. I want to draw a radius in here. No? The radius that covers that chord. Because I know that these purple lines measure 8. So if I know that these purple lines measure 8, I know that what I have in here is a right triangle. So by using Pythagoras theorem, the hypotenuse is 8. So it is 8 squared equals 5 squared plus x squared. So 64 equals to 25 plus x squared. O sea, subtracting 64 minus 25, that is is it 49? No, it is 39. Isn't that sad? Do the square root. So how much does this measure? This measures the square root of 39, which is around to 6.24. So the whole chord is going to measure twice of that. So the whole chord is going to measure 6.24 times 2, o sea, 12.49. No, rounding properly. Yeah, this is a toughie. O sea, I can tell you that I'm gonna ask something like this in the exam, and I am gonna keep asking things like this several times in this worksheet. Okay, like this seems intimidating, but definitely it is not. Let us walk through it. O sea, this is gonna be super quick. So if this angle measures 85, this angle measures 85. So if this whole angle measures 280, then this one measures 360 minus 280. O sea, this one measures 80. O sea, this one measures 80. Okay, so if this angle measures 150, that means that the central angle measures 150. And because this and this are vertical, this also measures 150. If this measures 130, then this one measures 180 minus 130 because they are a linear pair, so this one measures 50. If this whole thing measures 240 and this one measures 68, then this one measures 360 minus 240 minus 68. $52. Okay, if this one measures 90 degrees, that means that this one measures 90 degrees. If this measures 35, this guy measures 90 minus 35. Okay. If I find I want to find xy. Whoops. I want to find xy. So to find xy, observe that what I have in here is I want to find xy, but before finding xy, notice that in here I have a right triangle. And I don't have any type of right triangle. No, I have a 3, 4, 5. Use Pythagoras theorem if you don't believe me. This measures 4. So the whole thing measures 8. Okay. So they are telling me that PQ measures 24. If PQ measures 24, because I have a 90-degree angle, the 90-degree angle is telling me that I am splitting it in half. O sea, that this part measures 12 and that this part measures 12. Now I have a right triangle in here. No, I have a right triangle that is 13, 12. I need to use Pythagoras theorem, so that is 13 squared equals 12 squared plus x squared. O sea, 169 equals 144 plus x squared. I subtracted, that is 25 equal x squared. O sea, 5 equals x. O sea, that this little part measures 5. Here, again, I have a 90-degree angle, and they are asking me for OR. They are telling me that OT measures 9. And they are telling me that RS measures 18. If this measures 18, because I am splitting it in half, this one also measures 9. What type of triangle is this triangle? Okay, it is a right triangle. Two sides are the same. This is a 45, 45, 90. So without doing any Pythagoras theorem, I know that this measures 9 square root of 2. Okay. I invite you to do them, but like if you, if you are not, if you're struggling, you can keep watching. So ACB measures 110. Because I have a 90-degree angle, that means that I am cutting it in half. So this one does not measure 110. That one measures, so this would measure a 55, no? Because I am cutting the 110 in half. Also here, like imagine that I have all of this. This is, the whole circle is 360. So 360 minus 120, that means that, this angle is 240. And I am not cutting it into 2 equal parts, but into 3 equal parts. So 240 divided by 3, that is 80. Okay, so if in here I have a 90-degree angle, and the 90-degree angle, I am cutting it into 2 congruent parts. So this one is very easily 45. Okay, so if you haven't done your homework for the first lesson, this is what you should have completed. I know that there are some exercises missing, but that's okay because I just want you to focus on the ones that I did here, because I feel that those are the ones that are truly important.